Welcome, everyone. Thank you for joining us. I am Michaela Parker, founder and executive director for the Alliance for Data Science and AI, or ADSA, and I'm here to welcome you to our Listen and Lunch. This is an AI webinar series where we bring you experts from around our community to share their approaches in incorporating AI in teaching and research in higher education. Today, we will hear about how AI is changing the future of work for software engineers, data scientists, as coding may soon be automated by AI. Magda Balazinska is joining us. She will discuss how the University of Washington is reflecting on these changes and their implications for computer science curriculum and beyond. And a quick reminder that this event, like all of our ADSA events, is governed by the ADSA Code of Conduct, which you can find linked in the QR code on this slide. But first, for those of you that are unfamiliar with our organization, a little bit about ADSA. We are a community of data science and AI leaders, practitioners, and educators who believe in a just, equitable future where data science and AI are thoughtfully applied in all domains for the benefit of all. To learn more about our events and activities, we have our URL on this slide and another QR code if you're accessing by phone. So, as I said, today we are welcoming Magdalena Balazinska, or Magda as I know her. She is a professor, Bill and Melinda Gates Chair, and director of the Paul G. Allen School of Computer Science and Engineering at the University of Washington. Prior to her leadership of the Allen School, Magda was the director of the eScience Institute and my former boss, the Associate Vice Provost for Data Science, and the Director of the Advanced Data Science Ph.D. option at the university. Magda's research interests are in the field of database management systems. Her current research focuses on data management for data science, big data systems, cloud computing, and image and video analytics. So welcome, Magda. Thank you so much for joining us today. It's great to have you here.
Yeah, thank you for having me.
So let's just go ahead and jump right in. From your perspective, as the chair of the school, how have AI technologies impacted computer science and computational jobs as you see it, such as software engineers and data science, as well as computer scientists?
Yeah, great. Yeah, thank you, Michaela. This is a great question. I think that fundamentally what we are seeing is that AI is yet another tool in the suite of tools that help us build software maybe a little bit more easily or a little bit faster. So definitely AI has been making good progress in helping software engineers to automate the mundane, to automate the repetitive. So you don't have to remember, maybe the detailed syntax of something or how to call a library, because AI can kind of help you and can generate this. At the same time, I think for data scientists and software engineers, right, the coding part, the part where you actually write down, the programming language, those instructions, is really just a small part of the overall job. One analogy that is not my analogy, but I really like to use it, is thinking about architects and software engineers or data scientists in a similar vein. So if you think of an architect, they don't just build a house. They have to first talk to customers, understand their needs, understand what they're trying to accomplish. And similarly, as a software engineer, we have to really talk to customers, understand what they need, understand what it is we're trying to build. And those are typically bigger systems. So how do we then decompose it into pieces? How are the pieces going to be designed and how are they going to interact with each other? You need to think about the efficiency of the whole system, the ease of use, the security aspects, the privacy aspects, the reliability aspects, the availability, the scalability. There are many, right? And even once we start to actually build them, right? So once you have the design, you're writing some components, right? And then AI maybe can help write some of those a little bit faster. Then we still have to iterate, right? And understand what's breaking, what's not working. So there's a lot of that, problem solving creative work, and coding is just really a small component, but definitely AI is trying to make that small component be just kind of faster and more, more seamless.
Right. Yeah. Thank you for that. So pulling a little bit on that thread of preparing students for future jobs and future work. In a recent GeekWire article, and I will drop, or one of my staff will drop the link in the chat for those of you who haven't seen it, you shared that the Allen School professors have been encouraged to experiment with AI integration in the curriculum and use it, and the use by students. Can you share some examples of what that experimentation has looked like for teaching students? What
Oh, yeah.
kind of lessons? Sorry, go ahead.
No, absolutely. Yeah, that's a really great question. So we really are seeing kind of the spectrum. Some of our faculty members, especially at the introductory level, will say, well, okay, no use of AI in my class because you have to learn how to use it by hand, kind of like for calculators. We all had to learn how to do long divisions by hand, even though most of us probably will never have to do a long division by hand ever again after we kind of graduated, elementary school. So this is something similar. So in some classes, people say, well, let's first teach the students to do things by hand, so no use of AI. But in our advanced classes, faculty have definitely experimented with allowing students the use of AI in different ways. And we have seen different kinds of results. So in some instances, students can indeed do more because they can do things faster. So they can do bigger projects, more interesting projects. In other cases, though, without kind of appropriate preparation, students sometimes get into this building a house of cards. Like they rely on AI to generate things, but they don't quite understand everything AI generated, so they can't debug everything, and therefore they cannot build on top of it, and then they kind of get stuck because they have
Mm.
something that they don't quite and then they cannot kind of do the great projects. So as a result, really what we are doing for our curriculum is to explicitly introduce classes that teach students how to use AI correctly. And I think that's an important component of us as educators is we need to kind of learn it ourselves and then help our students figure out, okay, how do you use AI? How do you make sure that you generate code? Like, don't trust it.
Mhm.
Generate something, but verify it, have good, testing, have good specifications, good documentation. So we kind of, I think where we are landing is to have intro classes where students learn how to do things by hand. Now we have rolled out this new AI-assisted software development class, which is really meant to be like a sophomore level class. And then in the more advanced classes, hopefully by then students can leverage AI just like any other tool, but knowing how to do it correctly.
I really like that. I really like that the intro students are being encouraged, or I guess are required to learn how to do some of the tasks that AI could do so that they understand what is happening and what the best code looks like, right? And so then they don't get in that house of cards situation. I imagine some of that though is also a teachable moment, right? You kind of, I wonder like where that line is where you could let students do a little bit too far and see them fail.
Yes, actually, I agree with that. I always had the same perspective on software engineering as a whole. Like, as an undergraduate computer scientist, you are taught how to, how to do designs and build software well. But when you begin, you don't really appreciate. So it's almost good
Mhm.
to try to build something by just throwing yourself into it and writing spaghetti code and then suffering the consequences and then learning how to actually
Yeah.
do it. So yes, I think there is a little bit of that, that it's good to have that experience at some point.
I don't know how much you're interacting directly with the students, but do you see that there is an eagerness from the students to embrace these new technologies as part of their learning experience too?
So I think so. So definitely I work, especially in my director role, I spend a lot of time working both with graduate students, and it's
Mhm.
kind of, I mean, it's very compelling. Once you start to try to get the system to generate, it's like working with a very energetic intern, very enthusiastic, but not very competent.
Mhm.
Do things like, so you try to generate some code and it doesn't quite generate it. So you say, no, do it differently. And I think it's actually quite compelling and interesting. So for those I think who enjoy computer science in general, this is just another fun tool that is interesting to use.
That's funny you refer to the AI as an energetic but not very smart intern because that's exactly how Steve talked about he over the summer. Steve Van Tuyl, our program manager. Those of you who are interested, go check out our YouTube channel. There's a poolside chat I did with him where he reflects on his experiences of trying to use AI in a research project, and he described it exactly like that. So yeah, I think that's a common perception of how AI is helping us. So let's see. Next question that we were going to ask is, given that AI can increasingly automate coding, how are you and other educators at the Allen School helping students understand the value of human creativity? So I think you touched on the importance of human understand or the students understanding what the AI is trying to build for them, the idea of, the house of cards and spaghetti code and so all the pitfalls of relying too heavily on that technology. But is there a lens or a perspective on the involvement of humans in the loop in terms of just what makes us uniquely human?
Yeah, absolutely. And I think some of it is also how people think about computer science degrees and majors. They think mostly of it as all of us, in the basement writing code. But writing code is, again, just like a small component. So part of the computer science education, we will have some classes, especially at the introductory level, where we explicitly teach the task of writing code correctly. But most of our classes in those 4 years really are about creative problem solving. And most assignments, and I think that's what for those who like being in this major makes the major so compelling, that most assignments, most homeworks, most projects are about you're given a problem and you have to figure out how to solve it. So there's a lot of this creative problem solving, which includes understanding, again, like what your users, what your customers need, understanding how to break a problem that's large and complex into more manageable pieces, how to work with others on a team, right? Because most of the work is not lonely, it is collaborative. So how to work on a team, how to communicate with others, how to, so I think most of the work is in that realm. And then there's only a small component that's actually kind of realizing then the final product in this kind of code programming languages manner. And what's actually fun with AI is that if it takes more mundane work away, then more time ends up being spent, even more time is being spent on those creative and interesting tasks.
Yeah, that's a really good point. So, as you might know, many of our audience members lead data science programs. So, we've talked a little bit about how you and others at the Allen School have adapted your curriculum, some additional courses you've included. What other advice might you give folks who are starting or leading data science or computer science curricula to adapt it with these new technologies and prepare students for successful careers? And here, I didn't write it explicitly in the question, but we hear often this fear from students who are now entering the workforce that the entry level jobs are disappearing because AI is taking all of those intro coding, especially coding heavy positions. So what advice might you give others who are to adapt their curriculum and really foster students to be successful in this workforce that's kind of evolving?
Oh yes, that's important. I think the key for us as educators is to really expand our data science programs to be just like for ADSA, it's the Data Science and AI Alliance, and I think it's the same for our data science programs because AI really is integrated in two different ways. One, the way we have been discussing, which is AI can help us write code faster and in a less tedious manner, but also because AI is a form of data science tool. Like if you think of building models to do, better data analysis, this is also part of AI and that's part of data science. So I think if we expand our data science programs into data science and AI programs and make sure that the students who are data scientists learn these tools, they have a much better shot at getting good jobs as they graduate because they will know the technology. And one of my colleagues, Oren Etzioni, had this great quote. He said, you will not be replaced by AI, but you might be replaced by someone who knows AI better than you. And I think it's similar for the entry-level positions. So there are always entry-level positions because those will be the first positions people take when they start. But they might be different than what they used to be. So they used to be simpler, yes, write some code for me kind of positions. And now we assume that someone knows how to use AI and can do this more efficiently. And therefore, I think the entry-level position can become more interesting. But it's really important for people to deepen their knowledge and have that more advanced, skill set.
There we go. I muted myself. Yes, I completely agree. I think that's a really nice perspective to take. And this next question, it's a bit controversial. I know it's difficult, especially as the head of a school, to talk about faculty and faculty positions. But just generally, we see articles in the Chronicle and elsewhere that speak to the fears from some faculty that as they use AI as a resource for teaching, they're realizing how much more efficient they're becoming, but also just generally that AI can do a lot of the teaching tasks. One extreme example in the K-8 system are the alpha schools, where they've really re-envisioned completely what K-8 education looks like. I don't imagine we're going to do that anytime soon for academia, but I do wonder what trajectory we may be on from the faculty perspective, using AI, if AI it really becomes a core part of the operations and of the teaching of the university. Is there potential that, especially under a tough economy with budget constraints, that maybe faculty don't lose their jobs, but certainly hiring may slow down, right? And what does that look like then for postdocs entering the market?
Oh, I think so. So yeah, those are great questions. I think there's a couple of questions in your question. So let me try to tackle them maybe one at a time. The first question is just like the role of the educator, the role of the instructor. And here I would kind of push back a little bit with just using AI the same way as we have books. Like we've had books for a long time, and books have never replaced faculty members or instructors because while I can take a book and read from the book, or I can watch a YouTube video, or I can find examples online. And I was able to do that for a long time. A good instructor is so much more than just telling me orally what the book contains, right? Instructors inspire students, they draw connections, they explain the impacts, and classrooms kind of bring us together physically, which is just, I think, very energizing. And having that kind of in-person, college or school experience is very different socially and emotionally than just learning at home, whether it's from a
Mm-hmm.
book or from AI. So that's why I think the role of instructors remains critical because we can truly put people and help flame their passions and help put them on those explain things in a different way, have deeper discussions about the material, all those things. And I think this is the most important role of the instructors. And I think that, yeah, university schools, community colleges are always under budget. So if we can use AI to, again, off burden, like offload some of the tedious tasks, or maybe I explained something in a certain way. And if a student has access to AI to say, okay, I didn't quite understand when Magda explained the following, can you try to explain it to me differently? Or for example, like what always annoyed me when I was in school is you go to class, the teacher shows the simple example, and then you have the homework with all these complicated examples and there's a gap. Well, if I can use AI to say, okay, I didn't quite grasp this concept. Can you generate more examples for me so that I can practice? I mean, all of these are just ways to make the instructor more efficient
Mm-hmm.
and actually help the instructor spend more time on the fun part of teaching and maybe less time on the tedious part of teaching. So that's, I think, how we should be going. I think separately, of course, with everything that's going on, budgets and the economy, that is hopefully, that is definitely there's tighter markets, tighter times. Hopefully, it's a transition period, and kind of, and in the future we see kind of some brighter times again. But there was actually another great quote that I was looking at recently that says, life is not about waiting for the storm to pass; it's about learning how to dance in the rain, which I think is an excellent
Oh,
quote for the times we're currently in.
I love that. That is really beautiful. I'm going to have to use that. Thank you. But what you just mentioned before that, it reminded me of the flipped classroom. So I see where what you're describing to me sounds like an AI tutor or someone who can kind of support the instruction that the main class is experiencing. But then that does provide more space for the instructor to then do more of the discussion and engagement around that complex homework that you maybe didn't understand, but then the AI tutor helps you through. And then as a group in person together, we bond around our humanity, but also have fun, dissecting the problem and understanding how we all approach it. So that's
Yeah, I
really,
think so.
really nice.
I think so, but I think one of the challenges though is that sometimes students might not realize all those benefits. And I think
Mm,
one of the challenges we are facing is how to make it clear for students that showing up to class, engaging with their learning, and doing all those things is good for them in the long run. Which
mhm,
some students might think, oh, I can just stay in my dorm room, like use the AI and read the book and not really
mhm.
interact with others. And yeah, this is where maybe instructors we have to get creative about how to get there. Sometimes humans don't know what's best for them, and we have to
Right.
coax them into doing the right thing.
Yeah, well, and especially with the generation that came through the pandemic in their formative years, right? That there is a bit of that used to Zoom and online learning that, yeah, it'll be definitely a challenge to bring them all back. So I'm going to take a step back and give you sort of a meta question, and then we will open it up for questions in the audience. So those of you who are online with us right now, think about if you have any questions for Magda. There is time. You can either type your questions in the chat and I'll read them out loud, or raise your hand and I should be able to see it. So let's see, where do you think, this is a big one, where do you think the fields of computer science and data science are going as AI continues to improve? And I'll interject a little thing here where I think personally, data science hasn't even quite figured itself out yet. It's not quite a fully defined field, but it's getting there. Computer science has 50 years on us. So, but I think both are being equally impacted by this new technology. So what do you think the implications are for CS and data science as fields?
I think so. And actually good to remember that computer science is an older field because this is not our first transformation. So there's also another saying that says like, computer scientists always try to put themselves out of a job because we script the tedious, because we put things in libraries so we can reuse it, because we try to encapsulate like functionality so that we don't have to look inside it, but can just call it. Because we exchange examples to get to, we build compilers so we don't have to worry about the intricacies of the hardware in the system. And every time, what that has enabled us to do is just be more creative and do like, think of the systems from the 1970s and think of the systems we're building today. So much more exciting what we can do with the tools. And I think it's going to be the same for data science and the same with AI. This is another tool that will take some of the tedious away, allow us to go faster, do even more exciting things. And then where we are headed depends on our shared imagination. So I think there are many things we can do. And hopefully this technology just helps us get into the future faster.
Thank you for that. Okay, are there any questions? I'll take a moment to pause here in the audience. And again, you can type in the chat or raise your hand. I know this is our lunch and learn, so we encourage people to stay offline and eat. Oh, did I hear someone?
Sorry, I posted something in LinkedIn. So it complements what Magda was saying. Last weekend, we hosted a 24 hours coding challenge where students were forced to use code generation tool. And we gave problems that will take 2 semesters for students to solve without code generation, but they all solved it within 24 hours. Again, the solution is not perfect and things, but they were able to develop the solution, do the live demonstration of the solution. Yeah, so completely agree with what Magda was saying. Coding is still important. That does not mean we don't need to teach coding, but coding is still important. But them solving real problem and having more experience with that is more important in that sense. So we learned that no one should be producing software developers, but we should be producing software engineers because AI is the one that's doing the software developer's job. So it was very interesting. And many people now use code generation alone, not as a team. And that's what we forced people to work as a team. So it was pretty interesting learning experience for us on how to use code generation inside the classroom now. We haven't yet figured out, but at least we were experimenting this event to figure out where do we incorporate. So just want to share that.
Great, thank you for sharing. And where are you? What institution?
Sorry, I am from University of North Florida, which is in Jacksonville, Florida. And I'm in School of Computing and I run Florida Data Science for Social Work program. Thanks.
Thank you. Thank you for sharing that. Anyone else have a question or share? Yeah, that is very cool. Go ahead, Magda.
A really great example of what AI is really good at, this kind of fast prototyping. That's one right where you don't have to worry about the details. And if AI got something that's like the corner cases are not handled, etc., that's okay, because but it allows you to get to the prototype quickly. Therefore, you can explore that prototype, think about it, learn from it, and then build on top of that.
Yeah, absolutely. Anyone else want to chime in?
And it's actually interesting to hear what other people are doing AI related. So if anyone is doing something fun at your institution related to AI and data science, we'd love to hear.
And maybe while you're all thinking, I'll ask a fun question. Oh,
yeah, sorry, just
go ahead.
before someone goes, so I'll add one more thing. Just because the tool was there, that doesn't mean students knew how to use it. So many mistakes they were making because they don't know still how to prompt. Putting big prompt is not good. They need to be the planner as opposed to letting the AI be the planner. So there was a lot of lessons learned in how to do was there. Yeah, as Magda said, if we don't try it, we don't do it, we would not know how to teach it to the students. So that was very important point she made that needs to be highlighted again. Yeah.
Thank you. Thank you for that. We have some agreement in the audience as well. So we do have a question in the chat. Could you please elaborate on the specific kinds of activities or learning experiences you think CS students should engage in to become truly proficient with AI tools? For example, how valuable is it for students to build or fine-tune their own models? And how do initiatives like AI2 at University of Washington, shape or expand the opportunities students have to develop these skills?
Oh, great. Yeah, this is a great question and a very kind of very rich question. So a couple of thoughts. One is that there are indeed kind of different levels of learning AI, right? So we want all the students to have AI literacy so that they know whether they are at the University of Washington in other majors to have some, fundamental AI literacy so they can be just kind of, proficient citizens in the world with AI. We also want to make sure all the students learn how to use AI. So this is actually, calling the tools, knowing how to use them, when to use them, how to use them correctly. And I think to your point about like training your own model, fine-tuning your own model, I think for students who want to especially innovate in AI, whether as a data scientist, as a computer scientist, do you want to develop models, do you want to build the next generation of the technology, then for those, we really want to have a suite of classes on computer vision, natural language processing, deep learning, etc., robotics that kind of helps them learn that technology at the deeper level. And that's kind of the strategy we're taking, is to offer these different classes so people can dip their toes, can use the technology, in different contexts, and if they want to, can also learn the internals of the technology itself. And I think the other part of the question was related to AI too. So we have there's a couple of things. So one is actually just news from this week. We now have a new role of a Vice Provost for AI at the University of Washington. It's the current Vice Provost for AI, the inaugural Vice Provost for AI is Noah Smith, one of our faculty members, who actually is dually hatted. So he has an appointment in the Allen School, and he also is part of the Allen Institute for AI, which is AI2. And with AI2, we're doing a lot of exciting work that our faculty members are leading, especially around open source tools, but truly open source. Like think of what Linux did to operating systems. Is kind of similar, which means allowing the community to understand, have access to a world-class model that's competitive with the industrial models, but where we know everything about it, the code, how it was trained, the data that went into its training, etc. So we have a big project around that, and the goal is to really help the community have access to these open source tools and innovate and understand the technology and understand the responsible use of that technology as well.
I really love that answer. Thank you. I know we are at time now, so I wonder if in 30 seconds or less, you might be able to address. There's one more question in the chat from a student, so I want them to have the last word. A recent CS graduate, she didn't take any courses on AI, although they wish they did. Should they spend time understanding how AI works and maybe also machine learning before they try to integrate AI into one of their personal projects? They are working through some projects now, but still doing all of it without AI.
I think that's a great question. And I think it's absolutely important to learn AI. And I think all of us data scientists, computer scientists, we have to continue to learn kind of throughout our careers, because the technology today it's AI, tomorrow it's something else. That's what makes our lives and our jobs interesting. So yes, I would highly recommend learning it and then trying it and incorporating it. And to learn it, there's both kind of tutorials online. And I think starting from that makes sense. There's also different kinds of certificates. For example, we launched an AI certificate a certificate in AI, which is just a 1-year-long program. Other universities are doing similar things. So there's also these more structured post-bac programs that are available, but there's also online resources that can be an excellent starting point.
Oh, thank you. All right. I'm over time by a lot. Magda, do you have another 30 seconds for one more question?
No, thank you all for being here. But I have time. Yes.
Oh, okay. Just very quickly, a PhD candidate wrote in the chat, curious what advice you have for fields outside of computer science that are increasingly being infiltrated by computational approaches. In this case, for example, biology, much of the field is memorization, but now coding skills are necessary. How do you see foundational education for such fields incorporating these skills? And a side question, how do you see AI impacting skills, fields, knowledge that must be memorized?
Oh, this is a good question. But I think biology is so much more than memorization, like understanding everything from like the functioning of a cell and how the field is evolving. Like I just remember like when I was in high school, we just knew the cell was this blobby thing with a nucleus and some organelles, and we just draw these squiggly lines. And that was kind of the state of what we were learning. And now it's like so exciting, like everything that happens in the membranes and everything kind of how it all connects. So this is all very deep systems knowledge. So I think for those fields, again, computation, data science is just a tool like math. Like you need to learn the tool because that will help you become better biologist. So just embrace it, learn it, knowing that this is a tool that help you become better, and knowing that your expertise is in that depth of understanding, not just the memorization, but understanding how it all connects and then building on that knowledge. So biology, I think, is a fascinating field.
I do too, but I'm biased. I have an undergraduate degree in biology, so I +1 everything you just said. This is very good points about looking at these data and computational tools as tools and as supporting all fields. And I think that is a wonderful place for us to end. Thank you for staying over, audience. Thank you for also hanging on with us past the half hour. I could have gone for another half hour with you, Magda. This was really delightful. And I hope we see you again soon.
Yeah, thank you to all of you and all the great work you're doing. Thanks,
Thank
Michaela.
you. Have a good rest of your day. Bye, everyone.